In this lesson, I will explain how to construct a tiling using the TOPOSPro program and how to find the zeolites with the same tiles by the TTT collection. We can load CIF file with the zeolite framework from the database of zeolite structures www.iza-structure.org. It should be noted that any program of the program package TOPOSPro uses adjacency metrics, so its calculation is the first stage in working with TOPOSPro. If we construct tiling for a zeolite, we should do it for the framework containing only silicium atoms. So I should transform all oxygen atoms to the net edges. Now I run compound, auto-determine, simplify adjacency matrix, remove all 0, 1, 2 coordinated nodes. I have transformed the oxygen atoms to the edges. As you can see, we have only 4 coordinated silicium atoms, and now it's possible to construct tiling for the frameworks. I run ADS, Options, Topology. I have to set all rings option. The option ensures that all rings up to the size of maximum ring will be found. These rings are necessary for the tiling construction. The value of the maximum ring size should be not smaller than that of the biggest ring in the tiling. Of course, you don't know exactly the size of the rings, so better set maximum ring equal to 12, because it is enough for most structures. You should remember, the larger maximum ring, the slower the calculation. If you set a size of the maximum ring too small and a proper tiling cannot be constructed, then you should increase maximum ring size. Then I switch to the tiling tab. I have to specify the maximal number of the tile faces. The maximal tile size 200 is sufficient for most of the nets. I should check the natural tiles option. As you can see, the options locally strong rings and single tiling are turned on automatically. These 3 options ensure obedience of the tiling to the natural tiling rules. The rules and the algorithm for computing natural tiles are described in the supporting article. The option Determine Tile Topology is used for classification of the tiles. So I have to set the options Maximal Tile Size, Natural Tiles, Locally Strong Rings, Single Tiling, Determine Tile Topology, and Maximal Ring. I run ADS. It offers to select central atoms. These are the atoms to be taken into account during the tiling construction. I select all silicium atoms. Let's look at the output data. This is the information about all tiles and its properties. Each line contains information about the tile, the number of vertices, the number of faces, the number of T atoms in the ring, and number of the rings constructing tile. For example, this tile is constructed from 2 4-membered rings, 8 5-membered rings, and 2 8-membered rings. This description shows inequivalent rings constructing each tile. These are geometrical properties of the tile. Here the tiles constructing the natural tiling are shown in their stoichiometric ratio. The transitivity of the tiling shows the number of inequivalent vertices, edges, faces, and tiles in the tiling. D size is the number of primitive tetrahedra in the tiling. The larger is D size, the more complex is the tiling. This is the average number of T atoms in rings. The dangling edge option shows an average number of the atom's bonds, which do not belong to the tile. This table summarizes the main information about the tiling. To find the zeolites with the same files, you should load the TTT collection. So, database, collection, load tiles. This is the list of all tiles from which natural zeolites are built. Here you can look at the tile, determine which zeolites contain the tile. The option Select the tiles allows you to find all tiles forming the zeolite. Also, we can see all zeolites containing selected tiles. We also can search for any fragment of the tile in the TTT collection. For this purpose, you should select a part of the tile, save it with the GPH extension, and load it by the Fragment button. For example, these are all tiles containing half of the TOC tile. So, in this lesson, we have considered the TTT collection. For more information about tiling construction and other possibilities of the program package TOPOSPro, you may address to our lessons and webinars on our website topospro.com.